All right, I am here with the week 9 addition to the class for the LFSR Cipher. And ended class with this Google Sheet, which didn't go into any of the programming aspect of the Cipher, but it did go through the fundamentals about it and how it works. So, what I'm going to quickly go over this and help rebuild that fundamental thing. But from what I've heard from other students is that the main confusion is right now, how do I take these concepts and put them into REPL for Python? So the first thing that I'm going to actually do here for you guys on this demonstration is go back through this quickly on this Google Sheet and just talk about what is happening. So we start off with this example of the hats, right? Very simple. Imagine that this is a day. This is day 1. This is day 2. This is day 3. So on and so forth. And basically, these guys, these 4 faces, follow a rule for every day, whether they're going to wear a hat, because nobody can think for themselves. They have to look at what other people are doing. Apologies if you can hear my dog in the background. But I'm going to continue on here. So we start off and we look, and this is basically saying, okay, this guy goes off this guy, he goes off this guy, he goes off this guy. Everybody looks to the person to their left, and they say, well, what did they wear the day before? So day 1, the first day, our first guy and our second guy are both wearing hats, but these guys aren't. And now he looks to his friend this day. He says, I'm going to wear a hat tomorrow, too. He looks at his friend to the left and says, I'm going to wear a hat tomorrow, too. He looks. No, he's not wearing a hat. And then if we look over here at this final rule, this is saying if this one or this one, not and, if either one of them, but only one of them is wearing a hat, then he'll wear a hat. So you can see this shift down, and these 2 shift over. These 3 shift over, and then this happy face, the parenthetical happy face, looks to these 2. Neither of them are wearing it, so he will not wear one. Next day, this guy looks to his friend, not wearing a hat. Hats aren't cool. He looks over, is wearing a hat. Very arbitrary example. When it's binary, though, it just looks for what value the 1 or the 0 that it had prior. So each row is going to be called B, like B1, B2, B3, B4. And the one prior is going to be called B prime, which is this apostrophe. So this is, if this row is our row we're looking at, this row is our prime row. So I'm going to highlight some boxes here and just kind of show you a pattern. This is our first guy. We'll highlight this one light blue. And then we see that B3 the next time takes over, because you can see that in the rule setup there. And now that's taken over, and you can kind of see this pattern start to go. It goes across here. This is really only helpful, though, for this Google Sheets view when you're looking at it, or if you're doing it by hand. But what's important to know is that everything just uses the same number in binary that the previous, in this case, the number 1 higher used. And then our actual rule, these 3 are basically understood rules. This is our actual like mathematical rule, and this is saying B1 prime, this one, XOR when you're using binary, plus means XOR, B2 prime. So it's saying these 2. What's the XOR of them? So we'll highlight these. Let's make this yellow. XOR of 1 and 1 is 0. If you look here, XOR of 0 and 1 is 0. And it goes through and it generates this table. In Python, you will not be making the table, but you'll just be doing this stuff using functions. And what you're looking for is this. This is your key stream. This is how you are going to be changing your original plaintext. If you look, we can see we have, for this example, I used dad, the plaintext dad, and so I generated enough key stream in order to make that dad get as many characters as it had in binary. If we look down to this one, we can see that the rightmost columns are all the same for the rules. That's why I didn't specify it. But our actual action rule is different. We can see our B5 here is saying, if you look here, it's saying the XOR of this guy, and the XOR of this guy as well. So 1, 1, 0. If you combine all that, you get 2, which is just in binary 0. If you go to the next one, 0, 1, 1, same thing. 1, 0, 1, same thing here. 0, 1, 0, and then it becomes a 1. So it's about the rule that really generates the key stream, which is down here. And it seems like a random set of numbers. So you can see here, this is sort of what I was showing class afterwards during the questions for the people live. What our starting function will look like. So I'm going to go over here to this class Cipher help that I'm going to share in the Discord after this is published. And I'm going to start writing it. I will not write the whole thing, but it's fairly similar to the Cipher you used last time, just the plain XOR Cipher. All I have here is the binary convert, the text convert, and the XOR. But we'll just say our def LFSR. We're going to have our variables. We're going to have our plain, we'll just call it text. That's our original text. And then we're going to have our seed. For this time, I will only have you create a seed of 4. We'll just type that. That'd be like saying we're using this example, right? You do not need to go up to B5, only up to B4 as far as this class is concerned. If you wanted to, you could go further and have it adaptive to match any sort of seed length, but that is not necessary for this one. The first thing that you want to do, obviously, if you are doing it, text equals text clean. I don't have the function here, so I'm just going to make that a comment. We're going to want to remember to bring our output with the empty string, because that's where this all starts from. And then the next thing we have to do is, in order for these to know what is B2 in this row, it has to know what B3 is in the row prior. So the first thing we want to do is name each of these parts of the seed. So we'll say B4 equals, actually, oops, this is supposed to be just seed. B4 is seed of, we're doing our square brackets here, 0. If you look, 0 is the first element, which is right here on the left. Remember, B4 is on the left side, B1 is on the right side. Come down the next side, B3 equals seed of square brackets 1, B2, seed of 2, B1 equals seed of 1. We are going to have to actually give these B's and name them before we go into it, but I'm actually going to show you a little. You don't have to do this, but I'm going to for the sake of time. If you separate these with commas, it's saying this B4 is equal to it, and so is B3, and so is B2, and so is B1. Those are equal to open as well. So we're going to go through the next line. This is how we've figured out, okay, what's our seed? You're going to use pretty much the exact same for loop that you did on your end cipher for the XOR cipher. For I in range ... whatever you had, and then inside it, we're going to have our creation of the XOR. So remember, we're going, oh, excuse me, you're also going to need to turn your text equals text convert. Don't want to forget that. Of text. And this is, again, this function has to be done in binary. You can't do this with letters. You can't even do this with regular numbers. So we're going to go down here for our I in the, well, I'll just go ahead and I in range of the text. So what's happening here? What are we trying to do? Well, the first thing we do, if you remember, we took our key stream and we here's the key stream, XORed it with the plaintext binary, and that's how we got this. So we need to take each binary character and XOR it with its same position in the key stream. So a reminder, the key stream is the next letter in the next number, in B1. So our first thing we're going to do is we're going to say our sum equals, you can name these variables whatever you like, but that's just what I'm going to call it in this example. We're going to say is our XOR of our binary. If you look at here, the form is binary 1 and then binary 2. Our binary 1 will be text for I in range text. We're going to have I'm just going to say this in abstract terms. I will not give you the exact definition because you had this for your last cipher. We're going to have the XOR of the text and then the XOR of our B1. This will not be, this exact formation would not work for you. But I'll keep going with this example. And then once you've done your actual function, you remember you want to take your your output and add this character that you get, whatever binary character it is, and add it to the output again, just like we would for last time. But then we're going to have our stuff. Here we're going to have some things. And then here we're going to have our output guy. You should know by now exactly what needs to go in this if you are a long-time returner. And if you are not, I go through what goes inside this for loop in great detail in previous lessons, but this is building upon itself here. Next thing you're going to do, if you remember, the B1 is not the same. If you look down this column, it's changing. It goes between 1s and 0s in what seems like a random order, but it's not. Same thing with over here. It looks like a random order. If you even take this hat example, it looks like it's random what hat they're wearing. But it is able to be generated, and that's what gives this LFSR cipher strength. It can be recreated very easily. You can use machines to do it. And this is something that is very useful, especially when we get to these modern ciphers. They're easy to recreate, but they are very hard to guess. Anyway, what I'm going to show you here is at the end what we have to do in order to get this to work the next time. If you remember, if you look at this rule here, B1 turns into what B2 was previously. I wrote it out down here, but I'll write it out again in here. So our B3 becomes B4. Our B2 becomes B3. Our B1 becomes B2. Again, this is all coming from what I showed you in here in the Google Sheets. Look at the rule. What is it saying? It's becoming what the previous iteration was. Once we've gotten to the bottom of this is essentially, if we just I showed you like a little text here, right? This is saying B2 prime right here, because we've already gone through what B2 is equal to in this for loop. Now, B4 is a little bit different. Remember, this is what has the actual rule that applies something special. So we're going to go through, and for this example, you will have to change your rule if it is different for your cipher. For this example, I will do the same one I did up here, B1 plus XOR B2. And I'm going to reuse this XOR function. So I will say B4 is XOR B1, comma B2. Now, this is where I will stop being the Sherpa on your guide up this Everest. Now you know how you have your B4. How do we get our seed? This is defining this, and then I want this to go down the list and figure out the rest of this. I don't need to see this table, but I want the program to know what's happening here. If you use this code, it should be able to understand how this is, producing this key stream. But remember, like I said, this stuff right here, all of these, let's see, we'll change the borders, right? Because these are the ones that have a border, these are the important ones, right? Because they actually carry some weight. The seed is how we generate the key stream, and the key stream is how we change our plain text into ciphered text. This stuff has no direct use outside of creating the key stream. So that's why we only have functions for B1 and B4. B3 and B2 are only just carrying over, they're just copying. This is just learning, but even still, it's just sort of copying, just a different way. And this is essentially how we're going to produce this key stream. And remember, the key stream XOR, the plain text, gives you the cipher binary. If we take our DAD example, we took our using this binary, the DAD right here, with our LFSR key stream, which ended up being, let's see, I'm just gonna copy this and bring this down here at the end, and then I'm also gonna bring this just so we can have it here. So this ended up being, you don't have to know this, but our LFSR key stream, when converted into binary, again, you do not have to do this, but I think it's just interesting to know. That's part of, digging around this program. But our first character is period. I'm just looking up here at this chart that I already have set up for you guys. And then we have our parenthesis. And then our last one is our E. So this right here, this is our key stream in terms of the actual English language. Our plain text will be, if we look up, we just kind of have to find where these codes are, because I'm just doing it by hand instead of putting it at the computer, but I didn't want to show you guys the exact answer because I still have to leave something for you to do. You have to earn that $25. This is our ciphertext using, again, just binary. Normally this cipher would be done using ASCII or maybe base 64, but we are not going to really go into that. Next week during class I will mention what ASCII is and just kind of talk about it. But it's essentially, ASCII is just another version of binary. If we're being honest, it's just another chart that we're going to have to convert to, and that really is the least fun part about using binary, converting. So, for this example, for this cipher, I'm going to tell you now exactly what I want you to produce. I want a LFSR function that will generate a key stream using B4, 3, 2, and 1. And I want it to take in a plain text, convert it to binary, use the function, convert it back into text for our ciphertext. It should return over here ciphertext that has this alphabet that goes from A through Z, as well as period, exclamation point, question mark, parentheses, and a dash. So remember, at the end, you're going to have to use your binary convert. Actually, I put this wrong. it would start with binary convert, and then when you end it, by the end of it at some point, wherever you would have it, you're going to have your text convert. That'll be later on in your code. I want to input English with this alphabet and input that and output. I'm sorry about that. Output English using this alphabet as well. I really hope this has cleared up some of your questions. If it has not, as always, feel free to reach out to me. I am happy to answer any questions and go through what's going on. Some of the things I have noticed, I will say, is that a lot of you are complicating your code. Remember, you want to do it as much as you can with as little typing. That isn't a thing about being lazy, it's about being efficient. It's very hard to clean. If you let's look at these two for example. It's a lot easier to say, okay, what's the problem with bin string plus equals binary point I? Well, I mean, that's pretty easy. All right, but if we look here, oh my gosh. Dictionary of parenthesis bracket v comma k for v comma k in binary items. Yeah, that's just so much. So, granted, there are times that you're going to have long binary, but remember, the cleaner you can get it, the better it is. You can use multiple lines if you have to, but there are often functions that will help you. That's all I officially have for this lesson. If you have any questions, feel free to reach out to me. As always, the DMs are open. Thanks for coming.